From Central Point, Oregon, headquarters of Microvellum Software, this is Microvellum Live. Thank you so much for being here today. So for this week, we've lined up something special for you, a great topic. Actually, we're going to be continuing our conversation from last week where we discussed nested-based manufacturing and point-to-point saw manufacturing processes. This week, we're actually going to be talking about the different construction options that are available within our software in our cabinet libraries. And today we're going to be talking with Tim Skolman, one of our account reps out of Canada and a longtime product library developer. He's going to help us navigate through the different options for dado construction, lock dado, screw and cam construction options. And we're going to see how these various construction options can be set up for your default cabinets as well as custom items. So thanks for being here, Tim.
Hey, no problem. Good to be here, Clay.
All right. So we've had you on for quite a few live events recently, and I don't think we've ever heard your story. How did you get started with Microvellum?
Sure. So I worked for a architectural millwork and laboratory casework company, and I was brought over to the laboratory casework side to develop a software solution that was going to support our business. The company had tried a number of different things, Pro Engineer and a variety of other options, and had not been successful to that point. And so I was brought over to kind of look at systems and see what we could do. Looking at that side of the business, I figured that cabinetry could probably be done with something that had already been developed. And so we started just looking at all the different options that were available. And surprisingly, those options were less flexible than I had expected. And our choices were quite limited as far as software that would give us the flexibility that we were looking for. And so one of the big things that we did, our construction was a Tenon construction. So it was a mortise and tenon construction, and we used a machine something like the one on your screen there. And so that was about a 20-foot wide by maybe 30-foot long machine, and all of our horizontal parts would go through that, and it would machine both face and back of the part. If you have ever seen one of those, then you must have been in this business for a while. And definitely was a fast way to be able to adjust for the length of a part. Certainly not highly flexible. Outside of that, setup times were high and that sort of thing. But as far as running horizontal parts like tops and bottoms and being able to change lengths for those and quickly address those, nothing could come close to the ability to put parts through that machine. And so not a lot of options for software that would address that, and we came to Microvellum, and they were able to show us a Tenon construction that would address that, would draw the product in our software, and we were able to provide data to that machine in the form of labels and reports and things that they could then use to push that out. And so that's how we originally got started. The intention was to use Microvellum for all of our casework parts, and then we were actually going to use Inventor for our more custom tables and furniture and different components. And by the time we were kind of set up and running, we never actually opened Inventor. We ran everything through Microvellum full production going through there. And so that was in 2005 on version 6. And I kind of was in charge of manufacturing engineering for that company and ran production data library management for them. And then in about 2008, I recognized that that could be fun to do a few more times. And so came on with Microvellum as a service provider and did training and integration in Canada for our customers across Canada. And so have done that ever since, and now work as account manager and continue to support those customers in a slightly different role. So.
Yeah, it's been a long time, longer than I thought, actually, going back to 2005, for sure. All right, and so we got a chat already from Angel here. He's wanting to know, is that a double end? I think you commented on that in the beginning.
That sure is a double end tensioner, yes.
Yeah.
One might call it a boat anchor, but that's what it is.
Mm-hmm. All right, well, I think we're about ready then to get into the topic today.
All right. Well, you can go ahead and flip over to my screen, and we'll just dive right in. So as I mentioned, one of the things that brought us to Microvellum originally was the flexibility of that library and the ability to customize and share that. I'll go ahead and share my screen here. And customize the construction within the software. So today, most of what we're going to focus on is kind of the standard construction methods that are available for setup quickly, just with global variables and settings that we can set within the software. But certainly these are not by any means the limitation of the different options that are available right in the software by default, and certainly not the limit of things that you can add in and add to your library and configure that. The flexibility of things like Library Designer allow you to push those changes across the software, across your entire library quickly, and so that really gives you powerful flexibility when it comes to customizing your product construction to be exactly the way that you want it to be. So what I've done is just gone ahead and I installed the latest library. The last time I did a live event, one of my customers commented that I wasn't using metric data and I should be ashamed of myself for being Canadian. And so to honor that, I'm using a metric library this time. For a couple of reasons. Number one, because most of what you set up as far as construction methods really is based on a 32 millimeter or some equivalent of that when it comes to doweling and things like that. And numbers are just easier to work with than metric, in my humble opinion. So we'll go ahead and get started and just have a look. So what I did was install the metric 47.1 library for our customers on support. That's available for you to download on the forums, and you can access that. So 47.1, either metric or imperial, both are available there. So what I did, I just went in and created a new project. So I just have one project in this particular library, and I just created a number of different specification groups within that project. And so I'll just go ahead and open up a room and kind of show you what I did to set that up, and then we're going to walk through some different construction methods that are available inside of the software here. So let me just turn off my my visual style there, change that back to 2D. So lots of different options within the software, and you have the ability to set those things up directly from what we call our specification groups. And so when I draw the product out, the first one that it comes in with is Autospace Dowels. And so we'll go ahead and have a look at that. What we have is I'll just kind of walk through the content with you here. I do have a document that we'll post up with the recording that kind of outlines the details of what I've gone through and some of these specific settings and things, so you don't have to take all the notes, but you'll have that to reference back to along with the recording from this session. So what we'll do is I'll have a look at the specification group interface, and for those of you who are running on our latest 15.5 build, that will look familiar to you. If you're running on a older version or you're not using Microvellum software at this point, this might look a little bit different than what you're used to. But basically what I did was created a number of different global variable settings, and so those you can see over in my list of config components here. And so I have just these different options set up. Again, these are just some sample settings, and you can use any sort of combination of these as well. And so if you say, I want to use Dowel construction with screws or Dado construction with screws, you can certainly combine all of these to get exactly what you're looking to build with your system as well. So we'll go ahead and have a look at the Autospace Dowels to get started with. And so that's this system here. When we look at the dowels, the way that this system works is we specify a distance from the start of the panel. So from the front edge of the part, I'm going to go back by certain dimensions. So let me just open up the globals and we'll have a look at exactly where we can set those things and where we can make these changes. So first thing is we can select what type of construction we're using. And so that's going to be in a couple of locations here. We're going to go library construction and select on our different cabinet construction options, and then we look at our machining as well. So library construction is going to allow us to control, how the parts come together, where parts are over top of one another, how things are constructed that way. And then machining is where we're going to specify the the actual machining selections, diameters for the dowels. You have full control of all of that within Microvellum, and we give you complete access to be able to customize that. And so that's the beauty of the Microvellum solution, is that you have access to configure this in as much detail as you want, but the library does come with a wide variety of different options and configurations already built in standard that you just need to kind of turn on and off to get your settings the way that you need them. So under our general machining selections here, this is where most of our items are going to be specified. So if we look at boring patterns, so we have boring pattern for dowels, for screws, for cams. We have some invisible fastener options, and then some Dado construction options as well. And we'll get into each one of those as we go through the different specification groups and settings that we have here, but just want to kind of give you an overview of where you would set that. So these general machining selections, that's going to apply to the majority of the parts within your construction. But then within different components, things like stretchers, you might have a different machining setting for that. Maybe specifically for toe kicks, maybe you don't put dowels or screws on your toe kicks. You want to use a different machining operation for that, or maybe you dado your tops and bottoms, but you dowel or screw some other parts. You can certainly set that up. And so that's where we can set those things in the stretcher machining, nailer machining, toe kicks, and backs, and go through and kind of set our different construction methods within there. And so for this one specifically, the variables that we're referencing when we're using Autospace, so that's our boring pattern dowels, is set to Autospace here. And then when we go to our dowel and screw machining settings, we can go under our hole locations, and that's going to specify exactly where those things are to be located. And so here we have dimension to our first dowel hole, and so that's at 37 millimeters in this case. And we can specify where that's located, and then we have a dimension to the last hole, and so we specify where that one's located as well. And then we have a distance between holes for large and small patterns. And so based on what we set in our large pattern switch here, so we can specify that if a cabinet is greater than 356 in this case, so just over 13 inches, then we're going to switch to using 128 millimeters between the holes. Otherwise, we're using 96 millimeters between the holes. If you're working in Imperial, everything would be specified in Imperial here, and so you would do the equivalent of 96 millimeters. The only exception is dowel and screw diameters. All diameters are always specified in metric. And so other than that, you're going to change these values over to Imperial if you're working inside of Imperial. And so that's what that's going to do is specify that you have a hole a certain dimension from the front edge, and then it's going to place as many of these holes at whatever the spacing is, so either this 128 or 96 depending on the depth, and fill in the panel with those as far as it can go back, and then put one more hole 37 millimeters off the back edge. There is an option for that last hole to be specified on 32 mil centers, and so you can specify that from there as well. So when we look at the side of our cabinet here, if we look at our dowel spacing, this one is the screw spacing, but same sort of thing applies. We have a distance to the first hole, and then we have a fixed dimension that we specify, and then this last hole is going to vary. And so we have a distance to the last hole from the back edge, and then this last spacing is going to vary. So that method works really well if you have a CNC dowel machine where this hole is able to float from the back edge, or if you machine this in two separate steps, you might use that method, but generally it's going to be within a CNC dowel machine scenario where you're entering that. You do have the option to specify the height off of the table as well. So if you're using a fixed head dowel machine, you always wanted to leave that at a specific dimension, then you could do that, or you can set it to to center that hole on the thickness of the panel as well. And so if you have a CNC dowel machine, you want to make sure that's always centered, you can certainly do that in the construction holes Z value. Again, that's in the global variables there, and you're able to set those options within there. So we have dim to holes large and small. So when it comes to things like stretchers, maybe you use a different spacing for stretchers and nailers and toe kicks, for example. On those small parts, you might specify a different global for those, but you can specify the details in there for that as well. Then you have the ability to specify the diameters for your dowels, both in the horizontal and the vertical. So if we go back into our advanced project setup here and we go back to our global variables, we can go to our machining and dowel and screws. And if we look at our whole locations, that's what we've looked at here. Then we have face drilling variables and edge drilling variables. And so for our face drilling variables, we can specify what the diameter is. So maybe you're using a different type of dowel, something that clicks in or something like that. You might have a different drilling diameter for the vertical part, for the gables, for the sides, than you would for the horizontal parts. And you can specify that in here, specify what those depths are. And even if you're not drilling for those horizontal depths, if you're doing something like screw construction, you might not be drilling in the horizontals, and so you can specify that the depth there is 0 and it will turn those holes off. And so you can specify all the control around the diameters and depths for both the face and edge drilling for those parts, and work with your information from there. So that's the Autospace pattern. And then we have our fixed pattern. And so looking at this particular cabinet, we have a fixed pattern for that. And so this method works really well with a non-CNC horizontal boring machine, where we might have fixed heads on there and we insert drills into our 32mm boring machine at certain increments, and those are always fixed. They never change. You just put the part up against the fence and you drill that part regardless of its size. It just puts the drills that hit into the parts. And so that works well for a fixed head drilling machine. This is something where you might use a construction hole Z value because you don't want to adjust the height of the table. You could basically leave that machine set up and never have to adjust anything on the machine itself. And so that would be something like this fixed space dowels. And if we go to our globals for that, we would see we've got some different dimensions for that. So if we go to our machining and general machining settings, we've set that to fixed space in this case. And then on our dowel and screw machining, we've got our hole locations. And then we have down here, these ones apply to our dowel and screws. And so here we've got fixed dowel spacing locations for those. And so we have, again, small and large. So same thing as we looked at in the construction hole values, we've got a depth to switch to the large pattern. If you truly are using a fixed head dowel machine, you might not use the small ones. You might just say everything is drilled with these large ones and just set the small dimension to something that won't ever be reached, like 9,999 or something like that. And then it would only use the large drilling dowel holes here. So you can specify that. And then these are the actual dimensions from the fence to the center of each of your bits. And so here, if we have drilling at 2180 to 08, that's what we see in our drawing here. So regardless of what the part size is, it's going to always put a hole at a fixed dimension from the front edge and back, and until it can no longer hit those parts. And so here, our next drilling diameter, our hole 8, is outside the part. It is 656, and that's larger than our bottom panel, so there's not going to be machining that's included for that. So that system works really well with a fixed head drilling machine where you're horizontal boring on a fixed pattern, and you don't want to ever have to adjust the horizontal machine, and the CNC will take up for the vertical drilling in the cabinet sides in order to address that type of pattern. There are a couple of different options for how those things are laid out. You have dimension hole clearance from the back, so this is always going to place these holes inside of the back panel. So there's a global variable for how far from that back edge or from the face of the back that you want to place those holes. And so you have some control over how that pattern is laid out exactly as well. And so if you want to avoid having that drilling too close to the groove, you can certainly do that using the settings that are in there. And again, all of this information is kind of laid out in the handout that we'll put up with the recording there, and you'll be able to kind of have a look at that in a little more detail in there as well. So that's our fixed pattern. And then we have a custom space pattern. And so for our dowels, we have this custom space pattern. And so the way that this one works is basically it's similar to our fixed pattern where you have set locations for all of your holes, but maybe you vary where those locations are based on the depth of your part. So maybe if you're doing a shallow upper cabinet, you might have 4 dowels that are closer together, and so you've pulled out a few bits or you've put some extra bits in the front of your machine in order to do that horizontal boring on those parts. But if the part gets larger, you might pull out a couple of bits and make some changes that way. So again, usually used either with a fixed head or a CNC head horizontal boring machine. If you're using a CNC horizontal boring machine, you don't want to use barcodes for each part. That's certainly something that you can do with a CNC machine with Microvellum. You can just have labels printed with 2D horizontal barcodes for the horizontal boring, and you can scan those parts and run those programs directly. But if that's not something that you're looking to do, you don't want to include those barcodes, and you just want to use kind of standard programs out on your CNC horizontal boring machine, then you could have, if a part is from X to Y size, it's this program, and the operator then opens up that particular program to run those parts. And if it's a deeper part, then he uses a different program. You certainly have the control to be able to do that. As far as connecting to that horizontal boring machine, it's not a significant expense for Microvellum software. It's probably priced a little differently than what you're used to seeing if you're looking at other software options as far as how that is set up. So if it is something that you'd be interested, you can certainly talk to your account manager and see what's involved in getting that set up as well. So that's kind of for dowel spacing. So we have those 3 different spacing options for all of our different machining operations. So whether you're using screws or cams or dowels, those spacing options are kind of consistent throughout those different machining operations. And so the way that the custom spacing works is that there's a table that basically has the size of the part and then the size of holes that you would put in that. So if we go and have a look at that, we can go back to our project setup there, have a look at our auto-spaced dowels pattern. And if we go to our globals on this one, then this one is going to use a global variable lookup table in order to do that. And so to access our global tables, these are basically just tables that contain some information similar to what you'd see if you were looking at selecting a drawer slide. You would find different hole locations for that, and that's how a custom space pattern works as well. So if we go to our lookup tables, then we would see in our custom spaced dowels, for example, if the part is less than 50 millimeters, it's going to receive 1 hole at 32. If it's less than 104 inches, then it's going to receive holes at these locations. And so you can set these up at different parameters, whatever you want as far as where you want those changes to happen, and then what the hole locations for those parts would be. And so you can set that up just in a simple table like this and just specify, and these are just comma separated lists. So you just specify, I want one at 32 and then a comma, and then where your next hole is, and specify that out for all of your different sizes. So pretty simple to set that up and configure that to match exactly what you're doing currently. And so that's one of the reasons that people like to use the custom space is if they're switching from some other manual system or some other system and they want to keep a consistent pattern so that the operators are familiar with that, then the custom spacing works really well for that, because you can just come in here and kind of enter the variables for what your standard spacing that you're using right now, and set up the info for your patterns that you would use in the new software to make that transition as quick and easy as possible for the guys on the floor. And so that's going to be where we would specify our details for that inside of our lookup tables for those patterns there. So as far as dowels, those are usually pretty simple. You have a hole in the horizontal part and you have a hole in the vertical part. When it comes to screws, there's a couple of different ways that you might use screw spacing. So here you can see I've got my Autospace screws turned on, and you can see if I look at the details here, one of the nice things about Microvellum is that when you're looking at your data, this is exactly how it's going to go out to the CNC machine. And so when you're looking at a pattern here, what you see is exactly what's going to go out to the CNC programs. And so here, if I send this out, I'm going to get a 5mm hole in my horizontal parts at a certain depth here. And then I'm going to get, in this case, it's a 7mm. This is set up for conformat screws. So we've got 7mm drilling on the cabinet sides, and then we've got 5mm drilling in the horizontal parts. And so we can set that up however we need to for our specific screws. As far as the pattern itself, that's going to work the same way as our Autospace dowels, where we specify a distance to the first hole, an equal spacing for as many as we can fit, and then a distance to the last hole from the back edge of the part. And so we can set up our spacing that way. And we can do the same thing for our fixed spacing. So if we want to use fixed spacing for our screw holes, then we can do that as well. And yeah, it works the same way as our fixed spacing for the dowel holes. And then we can also use, when we're using screws, we might use something with Autospace with an equal spacing. So in this case, this is an example where I've got screw manufacturing, and a lot of customers will start this way if they're basically just screwing cabinets together today and they just get a CNC machine. They want to keep their construction method as they are for now. A lot of companies will just kind of get started with just pre-drilling for some screws, and then as they get familiar with that and comfortable with that, they might move to something more like a Dado construction or something else that they want to do on the CNC. But as a starting point, or as a pattern that you would use in conjunction with something like Dado construction on unfinished ends, then you might use something like this Autospace screws. And so here, the way this one works is similar to what we have on our regular Autospace pattern, but rather than specifying exactly 128 for the first number of holes, then we might just make all the spacing equal across. And so that works really well if you're drilling only in the vertical parts. You don't have to worry about the spacing of those holes matching up with a horizontal boring machine or something like that. Or if you just want to evenly space your dowels and you have a CNC boring machine, that's certainly an option as well to set that up. And so if we go to our project setup on this one, that would be our Autospace screws. Pre-drill screws here is how I have this one set up. And so if we go to our globals, we can set those settings. So this one, we've set the defaults here for our machining as Autospace screws, but then there's an option here for our screws to automatically center those locations, and so to use equal spacing for that. And so if we look at our distance between holes, so if we look at our dowel screw machining settings here, and we've got hole locations, we do have this option here for screws, space the screws evenly, and so that's going to use the distance from the first hole, different distance to the first screw hole and distance to the last screw hole, and then our distance between patterns, so large and small, it's going to use those as the minimum values that are the maximum values that it can use in between those screws. And so it's going to put as many screws in as it needs in order to avoid going over that particular spacing. And so that one works really well if you're just using screws to construct the cabinets, or if you're doing something like a Dado construction, maybe you don't have a case clamp to put those products in, and so you're clamping them up by hand, and you want to just throw in some screws to hold those things together while the glue sets so you can get them back out of the clamps. Then adding those screws in is kind of a quick and easy way to do that. A lot of companies will put the screws in anyways, but what we've seen is by pre-drilling those, it really makes the assembly a whole lot faster, where your operator doesn't have to worry about what angle he's holding the drill at, and able to put those screws in. By pre-drilling either with like a 5mm or a 3mm drill bit, you're really able to just quickly put a screw in there and hold the cabinet together that way while the glue sits up. So what you'll see here is that on this particular cabinet there is no machining happening on the opposite side, and the reason for that is these colors actually are set up in our drawing templates here to kind of give a quick indicator that this is a different condition here. So if I go back to the prompts on this one, what I've done is I've set the finished end on the right side, and so there are options within our global variables there to allow us to specify what happens at a finished end, and that could be different than what happens at an unfinished end. So if you're doing an integral finished end like this, where you're actually using finished material for the part, most often you're not going to want to drill through that to put a screw through it. And so maybe you're going to replace that with some dowels or change how that's constructed. Then you can set that up. And so in order to do that, we can set up our settings here so that as soon as we turn on left finished end or right finished end, when we're not using like a post-laminate condition, then we can drill only at those unfinished ends, and then we can use dowel spacing for the others. And so if we look at let's say this one, let me see if I've got that set up on here. If I go to this and put a finished end on it, I think I've got this one set up so that it will put some dowels in when I put a finished end on the cabinet there. And so it just makes it easy to assemble in all those locations where you are able to show some exposed screws, but in those locations where you can't show exposed screws, so like this, we're going to set it so that you can use Dado construction just for those particular parts. And so trying to get the most efficient assembly method possible there, but then also respect your finished end conditions and find ways that you can assemble that accordingly. And so if I go to our advanced project setup here and we go to our Autospace screws, I'll just have a look at some of the things that we've changed in order to make that set up the way it is. And then the first thing, if we go to our machining settings and go to our machining selections, you can see here that we've got both dowels and screws turned on. And this is certainly something that you could do. Even if you weren't doing it for this reason, you might alternate those dowels and screws. So put some dowels and some screws into your products. You could certainly do that. In this case, though, I'm just turning those patterns on so that in the case where I do have a finished end, that it's going to turn those dowels on in place of my finished ends there. So if I go to my machining tab here, there are some additional machining options here. So if I go to my dowel and screw location settings, I've got some additional variables down here. And so there's a couple of things that I've done here. I've set screw drilling at finished ends. I've just set that to no machining. I have the option to either drill through. So maybe you're going to do some caps on those screws or something like that, then you could set it to drill through. But in this case, I've set it to no machining on finished ends for the screw drilling. And then I've got this variable here that says don't drill dowels on unfinished ends. And so that's what I've got here set up. And so that means that when I have a finished end, it's going to drill the dowel pattern that I've specified. And when I have an unfinished end, it's going to drill the screw pattern that I've got specified. And so just allows you some flexibility as far as how you construct those products. And the goal is to give you the most efficient method of assembling those cabinets that works for you and give you control over how you're going to construct and set up those products. And so that's the different kind of screw and dowel construction methods that we have set up by default within the software. Then we'll have a look at some other options here. So we've got screws, dowels, and then we also have the ability to do cam construction here. And so this would be like a knockdown cam fastener, and you're able to set that up with a number of different options as far as what types of cams that you want to use. This one in particular is a Rafix cam that has the 20 mil diameter hole right up against the edge of the panel, and then it has an additional 8 millimeter hole, 8 or 10, back from the part by 32. And so that's how this one is set up. If you're using a different style of cam that would just have one large cam with maybe some horizontal boring on it, you have the option to set that up as well. So if we look at our construction method for this particular cabinet, we can go back to our globals. Again, these things can be changed locally. So if you have one product that you say, oh, this is a really big cabinet and I need to turn on cams for this particular cabinet, one of the things that we can do is with our newer libraries here with the carcass-based subassembly is actually go into the prompts for this particular cabinet and make the changes right in there. So there's a couple of ways that we can do that. We can go to our product prompts and then go to our subassemblies to access those prompts directly from there. Or we can go in through modify subassemblies and say show subassembly prompts. And so in this particular cabinet, I can go into my subassembly prompts for this one. And on my machining options tab here, I can specify all those same things that we've been looking at to this point. I can specify my Dado, so you can see here I've got all these things turned off because I'm actually using CAM construction for this particular specification group. But if I wanted to do this just on this one product, this is how I could go in and make those changes in here. So in general, today we're looking at kind of overall how you set up your library and how you can configure that to the way that you need it. But certainly Microvellum has the flexibility for a one-off construction to be able to set up a different construction method for that particular item. And so here we've got our CAM options, and so this is reading from our globals. And so that's the way that the products work in Microvellum, is you set your defaults in the globals, your project specific or a section of your project specific construction methods. And that's the power of the specification groups, is that really allows you to control independently maybe one room or an island or some specific large cabinets you might want to assign to a different specification group like I've done here. In this case, I've assigned a different specification group to every one of these cabinets. Probably wouldn't be the way that I'd do it if I was just doing one cabinet, but I just wanted to show the different options that we have in here. So if I go into my Autospace CAMs, we'll just kind of go through a few of the settings for CAM construction here. And so if we look at our CAM machining and settings, we've got some general settings. So this is graphics CAMs. So that's the type of CAM that we're showing here. If I uncheck that, it just changes some of the CAM location settings. So it's just kind of a quick set button to be able to change those options within there. So here I've got my what face that I'm going to machine those on. And so with CAMs, that does come into play because you want to be able to make sure that you can machine those parts as efficiently as possible, but then also not see those CAMs wherever possible. So if you are assembling those parts and you want to machine all the CAMs so that they're all visible on the inside of the product, then you could specify that. In this case, I've got my CAMs machining from the outside, so I'm on my bottom panels for base cabinets. I'm specifying that they're on the outside, same thing for the tops. But on my upper cabinets, because the upper cabinet is exposed on the bottom, I'm putting them on the inside. And so I can specify which face those CAMs are going to be machined from and control how that's set up. For all the different types of different cabinet parts that I have inside of my products. And then I have my location settings. And so here, depending on what type of CAM construction I'm using, I have those locations from the edge and from the front edge and from the back edge for where those are located that way. Distance between CAMs when I'm using like an Autospace construction, how those are being placed. And then also all of the detail of exactly where I'm drilling those parts, whether I'm drilling in from the edge with a horizontal boring, where those holes are being located in Z. And really gives you ultimate control to be able to use any type of CAM construction with the software here as well. And so you can set that up and configure that to your particular construction methods there as well. Depending on which type of CAMs you're using, you can set that up to your particular construction methods. Then we'll switch over to some other more woodwork specific, I suppose. That's probably a bad term, but these are our wood joints, more so than mechanical fasteners, where dowels and screws and things are more of a mechanical fastener. The Dado construction is more of a wood-on-wood style of construction. So this is the type of construction that we would have used something like this when I was working for a manufacturer and we set up our work for the double end tenator. We were actually using a variation of the lock Dado construction. And so the difference here between the full Dado and the lock Dado is the size of the groove that we're cutting into the associated part. And so here you can see I'm using a full Dado on those parts. And that means that for this 3/4 19 millimeter thick panel, I'm running a full thickness groove, and I'm going to insert that full panel into the associated part. The challenge with this type of manufacturing is that materials do vary in thickness. And so when you go and insert that part, you're not controlling that at the machining level. You're trusting the thickness of the materials that are coming in order to assemble the products that way. And so That's one of the drawbacks of using the full Dado construction. But if you have consistent material thicknesses, or if you have a little bit of variance where the parts can stick out the top of the cabinet, then that's certainly an option for you. The benefit, of course, is that you're only machining one part for those items. You're not machining the face off of those parts. In this case, I've got it set up to notch front and back for those parts, so I am machining them. Typically, this type of system, either Dado or lock Dado, works really well inside of a nesting environment where you can do everything on the table in a single operation. Obviously, running lock Dado or full Dado means that there is more machining that's happening on your CNC. So something to think about when you're deciding on a construction method is how busy that CNC is going to be. So if you're just getting into the world of CNC manufacturing, and maybe you bought your first machine and you're looking at, what type of construction method are we going to use with that, I would encourage you to do something a little more than just screw construction. If you're used to just using screws, there are definitely ways that you can improve your assembly times by adding some additional machining, and Microvellum gives you the tools to do that fairly quickly and easily once you've got that set up and dialed in. That applies to all of your products, so certainly something to think about. But when it comes to dowel manufacturing, one of the big benefits that we talked about last week was that difference between nest-based and pod and rail-based manufacturing. So when it comes to something like a dowel manufacturing, you might be machining only the cabinet sides on the nested machine, where you're drilling some dowel holes in the face of those parts. But then for your tops and bottoms, maybe you're taking those to a saw and you're going to cut those parts out just squares on the saw, and then take them over to a second machine, to a horizontal boring machine, a dedicated horizontal boring machine. And so that's going to free up time on the CNC. So if you're looking at ways to improve your throughput on a nest-based CNC, that's certainly something that you might consider, is like a dowel construction and adding a less expensive horizontal boring machine, as opposed to adding a second flat table CNC machine. So just some considerations there when you're looking at what type of construction method. So this one is certainly going to have less time on a flat table CNC if you take off the horizontal parts and you cut those on a saw outside. Same thing for screws. When it comes to Dado construction, those parts are going to take more time on the flat table because you are doing more machining on those parts as they come off. The big benefit for this is if you're not running that CNC at 100% capacity, you can just load the sheet on, and when the parts come off that machine, they are completely ready to assemble. You're not taking them to a secondary operation in order to do additional machining in order to put those together. So often, if a company is just getting started with a flat table CNC, they'll go with a lock Dado construction because it takes less footprint, less additional machinery in order to do that machining operation. You're able to do that all inside of just a single flat table CNC. So we have customers of all shapes and sizes, from customers that run hundreds of cabinets a day through all sorts of different machining operations to one or two man shops who just have a single flat table CNC, and they're able to use the software configured with these different machining methods in order to make the most of their machine and make the most of the space that they have to work with. So when we look at this Dado construction, those are kind of some of the reasons that you might go with something like a full Dado or a lock Dado construction. As far as how that's configured, we'll just have a look at the lock Dado construction. If we go look at our advanced project set up here, we can look at our different globals, and we'll just go with a lock Dado here and go into our globals for that. And so here, if we look at our machining operations, again, we've got some general machining selections. So here I've got use Dado set to lock Dado. We can specify whether on drawer divisions and other divisions we want to use Dados, sometimes based on that material thickness issue, or trying to flip the part so that the Dado is in the right direction. Some companies might just want to use some screws on the top of Dado's divisions and put those together as needed. So you have some options there as far as how that machining is set up. But here I'm going to specify my use Dado, and then under my Dado machining selections and settings, I've got Dado depths, and so I've got cabinet Dado depth, and so that's how far the part is actually going to go into, so the associated part here, so how far my bottom panel is going to go into the side panel. And then I have some gaps in addition to that. So with these construction methods, you want to make sure that you have some space for glue and a bit of play when you're inserting those parts. And so we have the actual finished thickness of the dado, and then we have the size of the groove that we're going to make for that. And so here we've got a gap at the bottom to give us some space for some glue. And then we have a dado width gap as well. So for this one, we specify the thickness of our dado. So if I'm using a full dado, that's going to be like my 19 millimeters plus 1 millimeter in width for this particular part. I've got it set to 0.5 mil there. And if I'm using lock dados, same thing. I might specify that my lock dado amount is 9 millimeters, and then I'm going to cut a groove at 9.5 wide. And so that's where I'm going to specify that. And then I've got the ability to start and stop my dado inside of my part. So this allows me to keep tight joints up front and not blow through my edge banding. And so I'm going to notch those parts in order to address that. And so if I look at my construction setup here, I've got my my dado construction here. So I've got my cabinet dado depth as far as how far that part is going to be going in. I've got my stop dado front length. So this comes into play when you're running the edge bander. You want to make sure that this dimension is large enough so that you can get your tracing wheels and your cutoff knives coming through there correctly. So you want to take that into account when you're setting up a dimension like that. And then we're going to leave a bit of a gap there to account for the radius, and so that's our stop dado gap. And so that's going to be the gap when those two parts come together. You're not going to see it. It's going to be a void inside of that groove that you'll never see. And there will be a little bit of a radius on those parts depending on how you machine them. And so that's going to take that into account. And then when we cut our groove, we've got our cabinet dado depth, so this dimension that we're actually putting that part in by, plus the 2 millimeters of our dado depth to give us our dimension there. And then same thing for the width of our dado. We've got the thickness of our panel plus the gap there. So my panel was 19.1 thick, and I had a 0.5 mil gap in there in order to give me the size of my dado. I have the option for a rear stop dado as well. And so depending on how you want to construct that, you have full control over exactly how you want that dado constructed, where you want your nips, and how you want that set up and machined. And so for a lock dado, I've just got a dimension as far as how deep I'm machining that, and so the thickness of the dado itself, and then again, same thing, I've got that gap, and so that's going to give me the size for my groove with my stop dados and all that info on there as well. So that's how I would configure my dado construction there. A couple of other options for machining we're not going to get into in too much detail, but we have support for lock dowels, we have support for fasten link, lots of different machining options within there, and that's going to do all of the machining on the CNC for those parts for however you want to construct those. As far as the construction options on there. That's kind of the overall construction as far as your machining options. A couple other things that you're going to want to take into account when you're setting up a new library is the back construction for your cabinets. So here you can see that some of these have nailers and some of them have full thick backs in them. And so if I go into my project here, I just threw open a room with some back construction options in it. And so here you can see I've got lots of different options as far as how I construct my cabinets from the back as well. So again, looking to address your standard construction methods, Microvellum has a wide variety of different options for how the machining comes together there. So looks like we've got a poll going up there with regard to our invisible fastener options. You can just go ahead and have a look at that and just let us know what your thoughts are on invisible fasteners and how you're using those. If that's something that you're using in production, or if you're looking into those in the future, then you can go through and and just answer the poll there, just to give us an idea of how you would see those used, and how we can support that work. So we have certainly the ability to connect with those options there already built into the software. The fasten link and the lock dowel options are already configured and built in there with the machining that's required for those. But there's always additional ones that are coming out and being developed, and so we're open to your feedback there as far as how you're using those invisible fastener methods to address your production needs. All right, so if we had a chance to have a look at the poll there, then we can go ahead and have a look at our back construction options. Just a couple of other things to keep in mind as you're configuring your library. We have both thick back and backs with nailers within our cabinets, and so the difference there is a thick back would be something like a 3/4 inch panel that you would machine around into the cabinet sides and tops and bottoms with the same type of machining operations that you might use for tops and bottoms and other horizontal parts. And so it might be doweled or dadoed or lock dowels or cams or what have you. It would be attached with those types of methods. If you have a thin back, that would be like a 1/4 inch back where you're cutting it into a groove on the associated parts, and you're machining that way. So one of the things that you want to consider when you're setting up your library is how your back construction is being used. A lot of times we'll have customers that will use 1/4 inch backs for standard cabinets, but maybe it has an open finish on it, so you have to do a colored interior on a cabinet. And that one, maybe you can't get the colored melamine or the colored laminate in a 1/4 inch material, and so you might use thick backs for your open finish cabinets and 1/4 inch backs for all the rest. And so there's options as far as your back construction within there as well. So if we go into any of these and just look at our global variables here, we've got some options there for back construction. So if we look at our library construction, we have some cabinet back construction options, and we've got back selection. So as far as how we're capturing the backs, whether that's sides and bottom, tops and bottoms, finished ends, full applied, and there's options here for doing something different at a finished end. So maybe you apply your backs except where there's a finished end, then you want to capture it into the cabinet side. Maybe you find the applied back is the most efficient, but you can't show that edge at the finished end condition. And so there's some options there as far as how those are constructed. And depending on the cabinet construction, you might use a different construction method. So captured sides and bottom, maybe use that for your base cabinets, and captured sides and top. A lot of customers that are using leg levelers, they have to machine the bottom side of the bottom panel. And so if they capture the back on the top and bottom, they would have to do a flip operation for that part. Microvellum supports that either in full sheet flipping or individual part flipping, but it is a secondary operation. So if you go with something like a captured sides and top, you don't have machining happening on the inside face of the bottom panel, and so that just gives you the ability to only machine one face. So some of those things you want to take into consideration when you're setting up your library, and so that's one of the things that our technicians can work with you on when you're configuring these libraries. If we have somebody work with you to do that, either through training or remote services, some of those things that they'll help you work through. The benefit that I've seen as working with hundreds of different companies getting their libraries and configurations kind of set up is that I like to be able to see what different companies are doing and how they're using the software and how they're configuring it to their needs. And so that's some of the insights that our technicians bring to the table as well, is because they're involved with lots of different shops and configuring lots of different libraries. There's lots of different ways that we can build cabinets, and so there's benefits and drawbacks to each. And so in consultation with these guys and ladies is a great way to get some better understanding of how you can best use the Microvellum software inside of your operation. So we've got our back construction settings as far as how the product is actually constructed. And then here we have thick back options. And so these are our standard and our thick back construction options. And then in this case, I've said I'm using thick backs for everything, but maybe I only want to use it for my open cabinets. And so in this case, we're going to use thick backs on our open cabinets because that's the material that I can get with a colored interior. But my standard backs are 1/4 inch white, and I can get that off the shelf. Or some of my standard 1/4 inch colors, I might set those things up so that they're controlled in there. And that's the flexibility that Microvellum gives you when you're configuring the library, is that you have the ability to specify, if I make these 3 selections of materials, then I want to use standard backs. And if I use, these other materials, I want to use thick backs. And so that's the power of the software, is that you can connect those things and customize that to exactly meet your construction and your production needs. And so the library is incredibly powerful and just full of different options and settings that you can use. And then we give you full access to be able to construct and build the products the way that you specifically need. So we're not kind of tying you to any particular library construction methods. We give you full access to be able to configure that and work with exactly what you need in order to make your production options. Just a couple of options here on the backs here. This is how we kind of set up those details. So we specify a distance from the back of our product to the back of our back panel. So we've got a base back inset, so that's a global variable. And then we have a nailer sitting in behind there. We specify a back dado width gap. So same as our cabinet dado width gaps, we can specify that. And then also for the depths of our backs when they go in there. So the back is 6 millimeters into the panel, but we're cutting an 8 millimeter deep groove. And so we can specify all the details of exactly how that's constructed. Or maybe we do something like this where we machine out the bottom panel to clear that bottom groove out all the way to the back and just set those nailers in. So and put some screws or nails in to hold those things in place. So lots of different options as far as how your backs and details are constructed. And so we give you the ability to control that and configure that. And so the recent libraries there just have all sorts of controls and ability within that. And so hopefully this is just giving you a kind of an insight into how you would go and configure that and set it up to your particular construction methods. Again, there are many different construction methods that you can use. We've just kind of highlighted over a few of them. And you can certainly use them in combination, or you can expand on them and add to them as needed in order to meet your production needs. So I'm just going to have a look at the questions here and see if there's any specific questions. If you do have anything specific that you want to look at in any of these different construction methods, feel free to type that into the chat and we can have a look at that. The other thing I just wanted to show was just how this comes out to manufacturing data. So I just went through and I created a work order for all of these products in a single work order here. And this just nested that out to a nested work order. And so here if I go, I'll just open it up because I already created it here. I'll just open up a work order that I created. And so it's got all of the parts and pieces that make up this group of products. So for each of these different construction methods, all of my parts and pieces are included in there. And so here you can see this is our processing center. So if you're not familiar with as far as manufacturing with the software, or you're using an older version and haven't seen this yet, this tool gives you the ability to kind of go through and sort through based on any of these different criteria and then assign parts to different stations. And so as we talked about last week, we can set up rules in our processing stations here that say, if I'm using certain construction methods with horizontal boring that happens on a secondary operation, to send those to a saw and send the rest out to a nesting machine, or, send this group of parts, anything that has horizontal boring, to a certain CNC, or how you want to do any of those sorts of things. So we can sort through here and just see how our machining is assigned to those parts. Here I've got my specification group name, so you can see I've got all of my different spec groups set up and assigned, and I process those through. And so now I just assigned everything to my default nest and sent that out to nesting. So if we go ahead and have a look at what we've got inside of our default nest here, we've got our different materials, and so we can just open these files and run them on CNC. Assuming that we've got our tooling set up and configured in there. So I'll just go ahead and open up this 19 white mel and just have a look at the composite drawing in there. So here you can see I've got the combination of all of my different machining operations in here. So here I've got some dowel manufacturing, I've got some cam manufacturing going on here. This is a Dado construction. So here you can see I've got machining going along to cut this tenon down to cut 6 millimeters off of it down to our finished thickness to control that for our Dado. You can see it's a red line, so it is a flip operation. So something you could consider here as far as construction method, you might want to change your back construction so that it's captured only on the sides, so that you don't have to do a flip operation on this. In that case, it would automatically machine those tenons right as part of the main nesting operation. And so just some different things to think about as you're preparing or looking at different construction methods, how you would want to handle that. We do have the ability to run phase 6 first as well. So if you are using Dado construction, there are situations where you're going to have machining on both sides of a part, and so those can be handled as individual part programs like this, or we can send the entire sheet out, machine those things with a couple of trims on it first, and then flip the whole sheet over, batch all that together, so you do that machining and part handling as simply as possible. And so those are some of the features that are inside of our software here to address some of the machining concerns. So here you can see I've got stretchers, and they're going to cut the notches on there, and then I've got this 6 mil routing to machine that down to its finished thickness as well. And so that's my Dado construction. Here you can see we've got, this is our fasten link machining. And so the way that this machining works is that there's a T-slot cutter that goes in and machines a groove to receive the fasten link connector. And then you snap those parts together. And so here you can see the machining that's happening 10.5 mil deep. It's coming in, plunging, or ramping in with that tool and cutting that T-slot in order to receive the fasten link machining there, and similar for the Dado construction. That's going to come through in there as well. I've got my cam construction there with my back grooves for those different parts. So all these machining methods that we've looked at here, these are the stock library setups. The data that I've set up, the configuration that I've done is just standard inside of the globals. So within an hour or so, you could certainly have your library configured to your construction methods. And so the nice part about that is that when I draw custom products, or if you need to build something specific, I can just do that inside with these construction methods as well. So if I said, I'm going to go in and go to my product starters, maybe it's not something that's standard in my library, but I can build something with any of these construction methods straight out inside of here. And so maybe I've got this vanity, and I'm going to throw in some different machining operations. I'll just put in a couple of different things here with sink with a false front and a couple of drawers, let's say. So I can just build up something custom like this, whether this is like a vanity cabinet or whether it's a tall starter for like an oven cabinet or something like that. Then you can certainly do that and just assign your machining to that, and it's going to go ahead and draw that product in with that particular machining. And so here I've got my Dowel construction, and I can just as easily change that to a full Dado construction. And so if I wanted to say, this one I'm going to use Dado construction on this particular cabinet, then all of that machining operation is going to follow through. So once I've got my library set up and configured to use these machining methods within my globals, then I can assign that to anything, including any sort of custom products. I had my Dados turned off for my stretchers, you'll remember, so I don't see any machining for those, but otherwise I've got my locked Dados coming through for all of those different part categories. So really flexible to be able to use the standard construction method that you've got set up, and then create any sort of custom products and items in there. I saw there was a note there about face frame construction. This is the metric library, so not a lot of face frame construction going on in these, but you certainly have the ability within the software to do that, and any of these construction methods that I've used inside this would also apply to my face frame construction. So if I go over and throw in a face frame cabinet out of the library, specify that I'm using, a certain construction method, then that's going to apply to those face frame cabinets as well. And so that's all. Once you've configured the library, the recent libraries here, we have both the face frame and the frameless construction set up in there. And so here you can see my dowel pattern has followed in for those face frame cabinets as well. So regardless of what type of cabinet construction you're doing, these construction methods apply across the board there as well. So, Clay, were there any other questions or anything else that came up in there that we should have a look at?
Actually, no, I think you did a great job answering a lot of the questions that were coming in. In fact, our team behind the scenes too was helping to answer a lot of those ones that streamed in as you were going through. So I think that works well.
All right.
Yeah, so again, thanks a lot for helping out today. Let me just get things shared over here on my side. Yeah, so if you're new to Microvellum, or perhaps you're just getting started, or maybe you're looking at even changing your construction methods, this is definitely going to be an episode you're going to want to watch again. And as Tim mentioned, we'll have the recording available a little later this week, and we'll also include that handout that was prepared for this episode that will allow you to follow along as well. And if you have questions about setting up your data, there was so much covered today, lots of different options that are available to you. Please let us know, and we can put you in contact with your account managers that can help guide you through this process of configuring your data. And so, yeah, like I mentioned, a lot of information we covered showing you the simplicity of the logic behind how we handle these various construction options and the flexibility there too. So thanks again, Tim, and we look forward to the next time you pay us a visit here on Microvellum Live. All right, let's queue up next week's episode. We are going to be having an opportunity to hear from a few of our techs and account reps here as we host another live Q&A episode. We're going to be diving into a few different topics that have come up over the last month or so, and we're even going to have a chance to take your questions live and demonstrate those answers for you. These are usually pretty fast-paced episodes, but we really have an opportunity to deliver quite a bit of information in a short amount of time. So I hope you can join us next week at 11 o'clock a.m. Pacific time. Another important event that I need to let you know about is our upcoming TechCon event. And so it's that time of year again where we host this user group and developer conference event here in Jacksonville, Oregon, just 10 minutes outside of our headquarters office here in Central Point. And this is going to be happening on May 3rd through 4th, 2018, so just a few short months away from now. And if you have not attended one of these TechCon events before, we host these annually, and they're attended by business owners, engineers, users of our software, people from industry, and maybe even those who are curious about our solution. So definitely encourage you to check this out. We're going to be offering group training on specific topics. We'll be breaking out into smaller focus groups, and attendees will have a chance to participate in a lot of discussions, some best practice discussions, not on just how to use the software, but in general shop practices as well and process. So you'll also have the ability at this event to participate in our developer conference as we review a lot of the suggestions that we collect throughout the two-day event. So your ideas that you submit at this event are reviewed by the team and those who attend the event as well. So if you'd like more information, as I mentioned, you can just check out our website at microvellum.com /TechCon-2018. So And also, if you have not done so, please be sure to subscribe to our YouTube channel, and that's where you can be informed of future live streaming episodes and recently uploaded ones. In fact, later today, you'll have the ability to watch the recording from last week's topic of nested base versus cell manufacturing. It'll be posted a little bit later today. So if you missed that one, you might want to check that out. On behalf of our team here at Microvellum, I'd like to thank you for joining today, and we will talk with you again on our next Microvellum Live event.